Hi guys! Trust that you have been well over the weekends. I'm not in school today, but over this video I'm going to be guiding you through the next part of the chapter on mole and chemical calculations. So please make sure you have this set of notes in front of you. Alright, now we have actually made a lot of headway in this chapter, but in case you forget, I'm going to do a little bit of recap first, right? And then today we will be tackling the last part of this chapter. We are going to be learning how do we derive concentration. Okay, so you should already know, right, the advantages of this being a video. That is, if there are any parts that are too fast for you, or if you need some more clarity, you can always pause the video and rewind. Nevertheless, if you are still unsure, please write down your questions so that when I come back to school, you are able to ask me these questions and I'm able to clarify them for you. Okay, so in front of you are a list of 7 words, right? We already tackled like the most difficult part of this chapter, right? We started off this chapter by looking at the relative atomic mass and relative molecular mass. As its name suggests, when I'm talking about atomic mass, then I'm referring to the mass of atoms, right? So atoms, for instance, I can have the carbon atom or even the oxygen atom, right? So if I'm talking about the relative atomic mass, then I'm looking at all of these atoms individually. So where do I find the mass of carbon or oxygen? Right, you should be looking inside your periodic table. In your periodic table, I am going to be looking for the mass number or the nucleon number. Right, so if you look at your periodic table now, you will see like a tile for carbon, right? Carbon will probably look like this, and then oxygen is going to look like this. Okay, so what is the mass of carbon? We are going to be taking the mass number, which is the bigger number at the bottom. So I know the mass number of carbon is 12. And then for oxygen, the bigger number at the bottom is the mass number. So the mass number of oxygen, or the relative atomic mass of oxygen, is 16. Right? Now this is different from the relative molecular mass. As its name suggests, we are talking about molecules, right? So in lower sec, you've already learned what the difference between atoms and molecules is. Basically, molecules refer to many atoms chemically combined together. Alright, so when I'm talking about relative molecular mass, I'll be not just looking at a single carbon atom, right? I will probably be looking at the atoms chemically bonded together. Like, for instance, over here I've drawn carbon monoxide. So carbon monoxide is made up of one carbon atom and one oxygen atom, so I can call them a molecule. But what is the mass of this molecule? Right, to figure this out, then we have to calculate the sum of each atom, right? Sum of the mass of each atom. So for carbon monoxide, I have one carbon atom and I have one oxygen atom. So the MR of carbon monoxide is simply the mass of carbon plus the mass of oxygen. So total, I get 28. Yeah, so this should be simple. Alright. Of course, we also briefly talked about what this term at the front means, right? We say relative atomic mass instead of just atomic mass. And we say relative molecular mass instead of molecular mass, right? So what does this word relative means? Relative just means a ratio, or it's a comparison, right, between the mass of, let's say, for this carbon atom or this oxygen atom, we're comparing them against a 1/12 of the mass of a carbon atom. Okay, so what does the relative mean? This means that the mass of the atom or the molecule, if I'm talking about relative molecular mass, is compared against 1/12 the mass of a carbon atom. Right, so like the key thing here is 1/12 the mass of a carbon atom. Right, this part may or may not be confusing to you depending on how strong your grasp of ratio is, right? But nevertheless, what is important at the end of the day is that you know how to calculate atomic mass and molecular mass. All right. Now, the other word that we learned, so the third word on this list is Avogadro's constant, right? So the magic number to memorize here is 6 times 10 to the power of 23. So this scientist called Avogadro decided, like since it's very hard to count individual atoms, let's collectively look at a group of atoms. Let's specifically, collectively look at 6 times 10 to the power of 23 of atoms and call them a mole, right? So 1 mole is always 6 times 10 to the power of 23 particles. Right, so this may seem confusing, but the way to understand this is using English, right? So in English, we're very comfortable with using, let's say, a pair of slippers, right? Or a pair of sunglasses, right? Pair always just means two things, right? So I can have a pair of gloves, I can have a pair of, I don't know, trousers, right? So got two, you got the two of the like leg pants, right? So a pair means two, and then like you also know 1 dozen means 12 things, right? So this we are already very familiar with. We are familiar with pair and dozen. So today in chemistry, we just add on to our vocabulary with just saying 1 mole. And what is 1 mole? 1 mole is a shockingly huge number of things, which is 6 times 10 to the power of 23. Alright, so when we were looking at the questions related to Avogadro's constant, there were mainly two types of questions, right? So I'm going to like quickly run through what these two types of questions are so that you are alert toward these. So if let's say I say I have 1 mole of oxygen gas. Okay, part A of the question, they can ask you how many molecules are there, and then they can also ask you how many atoms are there in 1 mole of oxygen gas. Right, so you have to be very clear about what the question is asking you, right? In part A of the question, they're asking you how many molecules there are, right? So if I'm looking at oxygen gas, right, oxygen gas molecule will look something like this. So if I have 1 mole, oops, I'm going to change the ink color. So if I have 1 mole of oxygen, I know simply by definition that there are 6 times 10 to the power 23 of oxygen molecules, right? Because oxygen molecules look like that, right? But in part B of the question, they didn't just ask you how many molecules there are, they're asking you how many atoms there are. So we know that in a single oxygen molecule, there are a total of 2 atoms or 2 oxygen atoms, right? So in 1 mole of oxygen, of course, I have 6 times 10 to the power of 23 of oxygen molecules, but that's not what the question is asking. They're asking about the number of atoms. So every 1 mole of molecule, I have 2 atoms. So I have to take the entire number and multiply by 2. Right, and then I'll get 12 times 10 to the power of 23 oxygen atoms. Alright, so all of this is to say you have to be very clear about what the question asks. Okay, this chapter is not difficult, you just have to know and be clear and answer directly to the question. Alright, now moving on from there, we had to be able to calculate the mass. So let's say I know the number of mole of oxygen, right? But how do I find out what's the mass of this oxygen molecule? Right, this is where we were introduced to our first triangle. So in our triangle, sadly we haven't really come up with an acronym yet, right? So any of you who have thought of a good acronym, you can let me know so that we can share our knowledge with the rest. Yeah. So in this triangle, we have mass, mole, and MR. Right? The MR here refers to the relative molecular mass. Okay. So if I want to, so same thing, right? If I have 1 mole of oxygen, so I'm just gonna extend this question, right? So I have 1 mole of oxygen gas. Then can I ask you, what is the mass? Oops. What is the mass of this oxygen gas? Right. So I have mole, but I want to find mass. So how do I do that? Looking at the triangle, if I want to find mass, right, you should be able to interpret this triangle very simply, right? So mass equals to mole times mR. Alright, so we come to this question, what's the mass of oxygen? Mass equals to mole times mR. Do we know the number of mole? Yes, because it's given in the question, right? 1 mole, so it's 1 times mR. What's the mR of oxygen? What's the molecular mass of oxygen? So you know that 1 oxygen has a mass of 16. So the mR of 2 oxygen atoms, or O2, it would be 16 times 2, so 32. So very simply, the mass of this 1 mole of oxygen gas is just 32 grams. Okay? Now, of course, coming back to this triangle, you should be able to manipulate this, right? So I can also ask you, I can give you like data about mass, and you're supposed to help me to calculate what mole is. So you should be able to derive this from the triangle. Okay, same for MR. Alright. So the important thing to remember is this triangle. So same thing, if you think of an acronym, please let me know. Alright. And the last lesson, we also went on to talk about the volume of gas. Right? And well, this one, you just have to memorize the magic number over here. 1 mole of any gas, right? Be it oxygen, be it carbon monoxide, being ammonia, is always going to occupy 24 dm³. Alright, so if I continue with my question here, I say I have 1 mole of oxygen gas. I've already found the mass of this 1 mole of oxygen gas. But in part D, if I've asked you, what is the volume of this 1 mole of oxygen gas, right? Then it's very simple, because we know that 1 mole equals to 24 dm³, and we conveniently only have 1 mole of oxygen gas over here, right? So what's the volume of this 1 mole of oxygen gas? Is just 24 dm³. Alright, so I'd just like to say and reiterate, right, this volume is the same for any type of gas. Even if I give you carbon monoxide, ozone gas, ammonia gas, they always occupy 24 dm³. Alright. Now, what is dm³, right? dm³, in case you forgot, dm³ in English is cubic decimeter. It's just another unit to measure volume, right? But the conversion here is important, right? So what is 1 dm³? 1 dm³ is simply 1000 cm³. Okay? So we have already covered most of this chapter. Today, in the next 10 minutes, I'm going to go through concentration. So what is concentration? Okay. To understand what concentration is, let's draw from our experiences from daily life. Okay. So let's just say, like, I'm going to prepare 2 cups of Milo. So to prepare Milo, I'm going to get a cup, and I'm going to pour like maybe 3/4 of the cup with water. Right, so I'm going to copy and paste this to show that in these 2 cups of Milo, I have the same volume of water. Okay, I'm going to call this cup A and cup B. Okay, now for the kick of it, let's just say, right, like in cup A and cup B, I have 20 dm³ of water. So they have the same volume of water. Alright, so like depending on what type of Milo you like, some of you may like it like super like bland and diluted. Some of you like it like super gao, right? Like very concentrated. So what does it mean? when we use words like diluted and concentrated, right? In beaker A, let's prepare a diluted Milo. So a diluted Milo, we just probably add 1 spoon of Milo, right? Whereas for a more concentrated Milo, we're gonna like spam the Milo powder, right? So I'm gonna draw like many crosses over here, right? And in fact, this drawing itself is enough and sufficient for us to understand what concentration means. So what is concentration? Concentration just means how much or what is the number or amount of solute dissolved or mixed. Okay, let's just use the word mixed lah. Mixed in a fixed volume of solvent or liquid. So in this case here, it is water. So it's how much Milo powder is dissolved in a fixed volume of solvent. So applying this definition back here, if we were to quantify concentration in cups A and B, right, I have the volume, right? So the concentration, I'm going to represent it as CONC, okay? Okay, never mind, I just write in full. Concentration means how much of a solute. So over here in my diagram, I have 1, 2, 3, 4, 5. I have 5 Milo powder in 20 dm cube of liquid. So the concentration is going to be, what is it? 5, 1/4, so 0.25, right? 0.25 Milo powder per dm cube, right? Whereas in cup B, the concentration is going to be, wow, there's so many crosses. Let's just say, right, I added like, I don't know, 20 Milo powders inside 20 dm cube of liquid. So it's just simply 1 powder per dm cube. Alright, and this is simply what we mean by concentration. And this fits very nicely with what we understand by concentration, right? If you look at the numbers that we have just calculated, A has 0.25 powder per dm cube, whereas B has 1 powder per dm cube. Right, this fits with understanding that B is more concentrated, right? Or A is less concentrated than B. Alright, so concentration is not too hard. It's just that we're going to learn new units about it, right? So in chemistry, when we talk about the amount of solutes, right, we cannot really count the number of oxygen atoms or the number of sodium atoms, right? So for amount of solute, we are going to use the units of mole. Alright, and then for volume, we are just going to use the units of dm cube. Alright, so the formula of concentration is simply mole divided by volume, so mole per dm cube. So over here, I'm going to introduce you to your second triangle. Right, so it's going to look like this. I'm going to use Conc as like a short form for concentration, okay? So similar to the mass, mole, MR triangle, you need to be able to manipulate the terms inside here. So if I have concentration in dm cube, I want to calculate number of mole, you should be able to do that, right? Similarly, if I give you a mole and concentration, you should be able to help me to find the volume. Alright, and then last one, concentration equals to mole per dm cube. Yeah, okay. Now, for concentration, some people are still like very unfamiliar with the word mole. So it is possible that we quantify the amount of solute not in terms of mole, but in terms of grams, right? Which is something that we are more familiar with. But in the same way, concentration is going to have a similar formula, right? Where we have gram divided by dm cube. Okay, so if you are looking at calculating concentration in the terms of gram per dm cube, then your triangle is going to look suspiciously the same, right? So this is your third and your last triangle to learn, where I have a mass at the top, so gram is mass, right? Same thing, count and dm cube. Okay, but in the same way, right, if I give you concentration and dm and volume, you should be able to help me to find the mass. If I give you volume, you need to give if I give you mass and concentration, you should be able to give me the volume. So all of this is to say that in the question you have to be very clear about what they're asking you for lah. They can ask you to calculate concentration in terms of mole per dm cube or gram per dm cube. Alright, so congratulations, you have just completed the entire chapter 8 on the mole, right? So for summary, you can refer to the notes, the first page of your worksheets, right? We talked about the Avogadro's constant, we talked about how to calculate mole, right? And then we talked about the first triangle between mole, mass, and MR. We also talked about volume of gases, right? And today, we completed this chapter by talking about how do we calculate concentration, right? So as shown here, concentration, there are two units that you can calculate them in. One is in terms of mole per dm cube and the other one is in gram per dm cube. Now before I let you go, I just have to alert you that sometimes questions will ask you to change between mole per dm cube to gram per dm cube. For instance, the question can say, okay, I give you 100 mole per dm cube of sodium chloride. Can you calculate for me the concentration of this sodium chloride in terms of gram per dm cube? So what the question is asking you to do is to convert between 100 moles per dm cube to gram per dm cube. Alright, so the way to do this is simply written over here. It is to multiply mole per dm cube by mR. Alright, so what's the mR of sodium chloride? So mR once again is the relative molecular mass. If you look inside our periodic table, the mass of sodium is 23 and then the mass of chlorine is 35.5. So the mR is just simply going to be 58.5. So coming back to this question then, what is the concentration of sodium chloride? All I have to do is to take 100 mole per dm cube, multiply by the mR, which is 58.5, and then I think we're going to get this, right? Gram per dm cube. Alright. So, in reverse, I can give you once again concentration in terms of gram per dm cube and then ask you to give me concentration in terms of mole per dm cube, and all you have to do is just divide that number by mR. Those of you who are interested, right, you'll be asking me, okay, I know this is the formula, but why is this the case? Okay, it's actually not that difficult. Some of you stronger in math would already see a pattern, right? So in order to convert between mole to mass, right, we have to look back at our first triangle that we learnt. So I'm just going to very quickly draw the first triangle that we learnt. Mass at the top, and then I got mole and mR, right? So if I got mole, right, and then I want to convert the answer back into mass. So how do I calculate mass? You know mass equals to mole times mR. So if I have mass divided by dm cube, right, and then I have I have mole per dm cube, but I want to convert it into mass per dm cube. What do I have to do? Same thing, just multiply by mR. Alright, so if you don't understand this, it's fine, right? All you have to do is to remember these two equations. Alright? Now, for homework, what you have to do is to complete classwork 4 and homework 1. So, I trust that you have already worked out all the answers in classwork 1. I've already shown you the answers for classwork 1. In the previous lesson, Daron actually helped us to calculate some of the answers for classwork 2. Alright, I'm going to let you check your answers over here. Do take note that in chemical calculations, we are always correcting our answers to 3 significant figures. Right, so please check, right, that you managed to convert it to 3 significant figures, okay? So classwork 2 should already have been done. We also did this, right? So those in like purple ink is done by Daron, right? So please check your answers, right? So your homework today for the rest of the period is to complete classwork 4 and homework 1. These should be quite simple for you. Alright, so they give you like mass, how do you find volume? Or they give you mole, how do you find volume? Okay, so do try it, look at your formula, always refer to your three triangles and think about how you can manipulate the values to get your final answer. Alright, now before I let you go, maybe let's try the first part of classwork 4 together. Alright, so here under classwork 4, let's look at level 1 questions. Okay, here I have a concentration in gram per dm cube. So in number 1, I have copper sulfate. Right, they say that the concentration is 16 grams per dm cube. In the next box, they want us to calculate the MR, or the relative molecular mass, right? This shouldn't be too difficult. Basically, you just find the mass of copper plus the mass of sulfur plus the mass of 4 oxygens. Alright, so from your periodic table, you should gather that the mass of copper is 64. Okay, and then you're going to add the mass of sulfur, which is 32, plus 4 of oxygens. Alright, so you're going to very quickly calculate this using your calculator. And your answer is going to be 160. Alright, so for MR, it's not that hard to calculate. Right, so now, they give you concentration in terms of gram per dm cube. How do we get the concentration in terms of mole per dm cube? How do we convert from gram per dm cube to mole per dm cube? Alright, if you look back at your notes, so flip back to your notes very quickly to find what the equation is. From gram per dm cube to mole per dm cube, you have to divide by the MR. Alright, so very simply, coming back to this question, right, they give you gram per dm cube. How do you calculate a concentration in terms of mole per dm cube? All you have to do is to take the gram per dm cube value to divide it by the MR, which is 160. So your answer is just, 0.1. I'm going to exercise good habit here by writing my answer in terms of 3SF. Okay? Now in the last column, they give you concentration in M. So I haven't really talked about this yet, right? M is actually, in English, we call it molar, right? Basically, it's the lazy chemist way of talking about concentration, okay? But 1 molar is simply 1 mole per dm cube. Okay, so like 2 molar will be equals to 2 mole per dm cube. Same thing, 0.1 molar is going to be 0.1 mole per dm cube. So the answer is just this. Alright. You should be able to do the reverse, right? So it's let's just jump the gun and look at number 3. So over here I have copper 2 chloride, right? They give me 2 molar. So what is the concentration in terms of mole per dm cube? Same thing if you look here, right? So my concentration is simply 2 moles per dm cube. What is the MR? We're going to calculate the molecular mass of copper 2 chloride. So 1 single copper is 64, and then 1 chlorine is going to be 35.5. So if we take 2 chlorines into consideration, and then we add this to the mass of copper, our answer is going to be 135. Alright, to fill in the first blank, right, we're going to do the reverse of what we had just done. How do we go from mole per dm cube to gram per dm cube? Alright, so if you flip up, right, to your notes, you'll realize that, okay, I just have to multiply by the MR. So the working is just simply 2 mole per dm cube times by the MR, which is 135. The answer is going to be 270. Alright, so I hope this is simple for you. Alright, so for the rest of the period, please complete classwork 4. Classwork 4 should be very simple. We're just going to be converting from gram per dm cube to mole per dm cube, right? Or they're going to give you things like this, and you're supposed to calculate the mass. How do we do that? Right, you probably need to think a little bit. Right, same thing. I have volume, I have concentration. How do I get mass? So in most of these questions, right, you are going to need to combine your ideas from all three triangles that you have learnt. So I would strongly suggest that before you start working on these questions, you make sure you have with you a copy of all of these three triangles. Alright, so this is the first triangle we learned, and then the other triangle we learned was about concentration. Alright, so you'll probably need to jump values between these two triangles to find out the mass or find out the answer for the questions. Alright, so try classwork 4 and homework 1, and I'll see you again next lesson.